Hi, and welcome back to Spaced Out. Today we are going to be talking about Kepler and its missions. Kepler is a space telescope that was launched by NASA. Its mission was to discover Earth-sized planets orbiting other stars, specifically to find exoplanets, what we talked about last time. The reason for specifically finding Earth-sized planets is because if they have the size characteristic of the Earth and are placed inside the Goldilocks zone from their stars, not too hot, not too cold, not too far, and not too close, they're likely to possess many other similar characteristics of Earth, namely life forms. It was named after Johannes Kepler, a German mathematician and astronomer who accomplished a lot, but arguably his most famous accomplishment was formulating Kepler's laws of planetary motion. Kepler was launched on March 7, 2009 at 3:49 a.m. The launch was very successful and everyone awaited the discoveries Kepler would make. Kepler was essentially an observatory in space that was looking for exoplanets, specifically ones that had similar characteristics to Earth. Kepler ended up running for 9.5 years. The original mission was only supposed to last 3.5 years, but was extended because of how successful it was. The way the planet selection process worked was a very thorough process. It scanned an area over a period of time using the transit photometry method. If you would like to learn about this method more in depth, you can refer to the previous episode on exoplanets. A quick recap on how it works is that the light emitted from a star is sent through a detector, and when an object passes through, there ends up being less light shining from the star since the object blocks some of the light out. They use this data to make a light curve and observe the light curves of multiple stars for periodic dips. If they see a periodic dip of 3 times or more, they consider the object passing in front of the star a planet candidate. Scientists then look further into the planet to characterize it in one of the exoplanet categories. It's important to scan for periodic dips to make sure that the object passing in front of the star is an actual planet going around on its orbit. This is shown through the periodic dips in the light curve, rather than just a dust cloud or asteroid, which wouldn't produce periodic dips, as they would just be a one-time thing. Of course, the question pops up of the planets that have an orbital period of more than 3 years. And unfortunately, during the time that Kepler was able to rotate and scan different parts of the sky, that was a potential planet candidate lost. However, on May 11, 2013, Kepler had a reaction wheel failure. Many people thought that that was the end of Kepler and Kepler's mission. However, the ingenious engineers that were working on the project discovered that while the wheel would make it so they couldn't rotate Kepler, it didn't mean that Kepler couldn't stay stable. Using the other wheels, they slowly moved Kepler so its back was facing the sun. The pressure from the sun kept Kepler stable while it scanned the area in front of it. Of course, this now means that Kepler can only scan one piece of sky now, but that ends up solving the problem with losing potential planet candidates that have an orbital period of more than 3 years. Kepler was and it continues to be an instrumental part in our search for life outside of the Earth. Thank you for listening, and I hope you learned something. Oh, and happy Pi Day.